Crop News, brought to you by the Kansas Association of Wheat Growers and Kansas Wheat Commission. Together, we are Kansas Wheat.
Dr. Trick, thanks for joining us this morning. Welcome back on the show. I think we had you on several years ago, so it's nice to see you again. Thanks for joining us. Changes going on at Kansas State University in the plant pathology department, which you work in. Tell us some of the things kind of going on there.
Okay. Well, one of the things that we do in my laboratory is we're working on plant transformation. So this is basically taking genes from different organisms and putting those into plants, try to improve them some way. It could be disease resistance, it could be drought resistance, it could be value-added traits.
Now, when we look at some of the past 2 summers that we had, drought being one of those, I'm sure that's probably something you guys work or trying to really work hard on.
There are some traits that we're looking at that have drought potentials in there, but primarily some of the work, especially in soybean that we're working on, is actually for soybean cyst nematode.
Okay, and for people who aren't really familiar with nematode, tell us a little bit about that.
Okay, soybean cyst nematode, it's a parasite, it's a worm that basically feeds on the roots of the soybean. And what this does is it reduces yield overall on the plant.
That's not tied in with sudden death, though, is it?
No, sudden death is actually a fungal pathogen, but sometimes these diseases work hand in hand. So if you have soybean cyst nematode in your field, you may have sudden death as well.
Big issue in dry versus wet soils as far as the nematode goes?
Usually the nematodes like sandy soils, pretty much, and more not really saturated soils, drier soils will be better.
A big issue this past year with it being dry like it was?
I believe it has been. Most of the work that we do in our laboratory really isn't in the field. It's more on the molecular aspects or tissue culture, where we take the genes and we try to put them into the plants.
And people who don't understand that, how do you gene sequence a soybean plant?
Okay, well, sequencing is a completely different thing. But what we do in our laboratory is we actually introduce the genes in. And the way we do this is either using a bacteria that actually infects the plant and in essence injects that DNA into the genetic makeup of the plant, or we use something called a gene gun. And this, again, we just will mix up the plasmids of DNA in a solution, and in the gun, we just push a button and it shoots it into the tissue. With this, what we'll do is, instead of just working with a whole plant, we work with cells. And these cells are in a petri dish. We will then encourage those to grow and develop into an entire new plant. And then these plants, hopefully, will have the gene that we try to introduce into it.
How long does that take?
It does take quite a while. It can be as short as 3 to 5 months, but typically it takes about 9 months to get a plant back from this process. So it's a long investment.
Lots of plants going on at the same time? I mean, or do you concentrate on one trait at a time?
We have a whole pipeline, so we actually have several projects going at the same time. We have several experiments. At any one time, we could have 50 experiments going on trying to introduce traits into those. And so a lot of this work, the Kansas Soybean Commission is helping us fund this for the soybean projects that we're working on.